Okay, in this video I'm going to finish up the Topic 8 worksheet here. We're talking about systems, and we've looked at some 2x2 examples there in the last video, the graphing method, the substitution method, and the elimination method. In section 6.3, your book focuses on solving three equations with three unknowns, and so I've got an example of that here. We're going to solve this system now. In that section, their strategy for solving was to use the elimination method repeatedly. Okay, and so I'm going to do that in this problem. Although I like the method of matrices better. It's usually faster compared to what we're going to do here. All right, that's all right. So I'm going to eliminate x to begin by working with the first and second equations. And then I'm going to eliminate x by working with the first and third equations. So with the first and second equations, I'm going to leave the second one as is, and I'm going to have to multiply the top one by -5. So then when I add -5x plus 5x is 0, x would be eliminated. And make sure that you multiply both sides by -5 here. Okay, -15x minus 6y is -21y. 5z plus z is 6z, and then on the right, -30 plus 5 is -25. I'm also going to eliminate x by using the first and third equations. To do that, I'm going to need to multiply the top equation there by -2. I'll leave the third equation as is, and so that way when I add -2x plus 2x is 0, x is eliminated. And then -6y minus 3y is -9y, 2z plus 4z is 6z, and then on the right, -12 minus 9 is -21. Now with these two resulting equations here, I'm going to rewrite them again. Here they are. And then I can use the elimination method again, or I could use the substitution method, because now I've reduced this down to a 2x2. I went with the elimination method again. If I just simply multiply the bottom equation by -1 there on both sides and then add, I can eliminate z. 6z minus 6z is 0. -21y plus 9y is -12y, and then -25 plus 21 is -4. Divide both sides by -12. -4 over -12 would be 1/3 when you reduce. And so now I can work backwards. Knowing that y is 1/3 means that I can find z by plugging that into either one of these equations. I went with the second one. -9 times 1/3 is -3, plus 6z equals -21. Add 3 to both sides and then divide by 6, so z is -3. And then knowing that z is -3 and y is 1/3 means I can plug those numbers into any one of these equations that were originally given. I went with the top one. 3 times 1/3 is 1. I'm adding -3 to that, so 1 plus 3 is 4. Okay, subtract 4, looks like x is 2, y is 1/3, and z is -3 would be the solution there. Okay, and I can check that, so 2, let's see here, where are we at? 2 plus 1 is 3, minus a -3 is 6, that's true. 10 minus 2 is 8. Minus 3 is 5, that's true. Okay, 4 minus 1 is 3, minus 12 is -9, that looks good. Okay, and so there's the right answer. All right, now the last option for solving a system is to use matrices. An augmented matrix is a special kind of matrix used to represent a system. A coefficient matrix is just a table of numbers arranged in rows and columns. There is no direct connection with systems. And of course our main topic for the chapter is systems. In an augmented matrix we must have the vertical bar. If we don't, then it's wrong, because we're talking about a coefficient matrix then, which is not the case here for the problems in this chapter. So be sure that you have the vertical bar there representing the equal sign. And I'm just going to simply pick off the coefficients that are in each equation and write them in the rows that you see here. So in row 1, equation 1, I got a 2 in front of x, a -7 in front of y, a 1 in front of z, and then a -1 on the right. On the second equation, I got a 1 in front of x, a negative 10 in front of y, a negative 3 in front of z, and then a 5 on the right. And then in the third equation, I've got a negative 3 in front of x, a 0 in front of y, I don't have any y's, and then an 8 in front of z, and then a negative 2 on the right. Okay, and so this would be my augmented matrix then representing the system. Let's write a system corresponding to the augmented matrix. We're going to have to know how to convert back and forth here. So here's an augmented matrix. As a system, I'm going to have 3 equations because I got 3 rows, and there'd be 3 variables, x, y, and z. So my first equation, I've got a negative 1 in front of x, a 3 in front of y, a 0 in front of z, and then a negative 4 on the right. In the second equation, it's going to be 6x plus 5y minus 6z equal 1. And then in the third equation, I don't have any x's there, so it'd be a negative 9y plus 2z equals 0. Here'd be my system then. Okay, there are row operations that we can do on a system, 3 basic operations. You can switch any 2 rows. You can multiply a row by a number as long as it's not 0, or you can add 2 rows together using multipliers. Okay, and that's essentially like using the elimination method but in a table format. So let's take a look at problem number 9. Apply the row operation, which is given here, to the augmented matrix. A capital R represents a new row, and a little r represents an old row. Okay, so in this problem, I'm going to get a new row 2. I'm going to leave row 1 as is, and I'm going to get a new row 2 by taking negative 2 times row 1 plus row 2. So let me do that. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 3 is 6, plus negative 5 is 1. And then negative 2 times negative 2 is 4, plus 5 is 9. Here'd be my new row 2. Okay, problem 10 is another example. Similar deal, only we got a 3 by 3 augmented matrix. I've rewritten that, and I'm doing 2 row operations here. I'm going to get a new row 2 and a new row 3. I'm going to leave row 1 as is. I've got that written again. And I'm going to get a new row 2 by taking negative 6 times row 1 plus row 2. Let me do that now. Okay, so negative 6 times 1 is negative 6, plus 6 is 0. Negative 6 times negative 3 is 18, plus negative 5 is 13. Negative 6 times 2 is negative 12, plus 6 is negative 6. And then negative 6 times negative 2 is 12, plus negative 7 is 5. I'm also going to get a new row 3 by taking 3 times row 1 plus row 3. So let me do that. 3 times 1 is 3, plus negative 3 is 0. 3 times negative 3 is negative 9, plus 1 is negative 8. 3 times 2 is 6, plus negative 1 is 5. And then 3 times negative 2 is negative 6, plus 10 is 4. Okay. Now, they're not going to tell us, what operations to be using. That's something that we're going to have to figure out on our own, when we're using the method of matrices. So problem 11 is my last problem here. We're going to use matrices to solve the system that's given here. This is a 3 by 3. And so here's my augmented matrix representing this 3 by 3. Again, I'm just simply picking off the coefficients in front of each variable. And I'll have 3 rows. Now the plan is to get this matrix into row echelon form. Row echelon form just simply means I'm trying to get 1s down the diagonal and then 0s in the lower triangular part. Okay, there's some other special conditions that would mean that you're technically in row echelon form, but that's pretty much what we're describing, is that we're looking for 1s down the diagonal and then 0s in the lower triangular part. There is an order to getting that form, and that is that you're going to work with the columns. Okay, get column 1 set, then get column 2 set, then get column 3 set, etc. I'm not going to give you bigger than a 3 by 3 on any assignment. So to me, I think if you can do what we're doing here with a 3 by 3, I think you got the idea. Step 1 is always to get a 1 in the upper left-hand corner. We've got that. And so now directly below that 1, I need zeros, okay, because I'm going to need column 1 set. So I'm going to need a new row 2 and a new row 3, since I'm going to need 0 leading off on these two values. Well, to have this 2 turn into a 0, if I take negative 2 times row 1 plus row 2, negative 2 plus 2 is 0. And let me see what the other numbers are going to be. Negative 2 times row 1 plus row 2. Okay, so negative 2 times negative 3 is 6, plus 1 is 7. Negative 2 times 4 is negative 8, plus 1 is negative 7. Negative 2 times 33 is negative 66, plus 3 is negative 63. I also need a 0 here in row 3 leading off. Right now it's a negative 3, so to have that be a 0, I could take 3 times row 1 plus row 3. Okay, let me do that. 3 times 1 is 3, minus 3 is 0, that's what I need. 3 times negative 3 is negative 9, plus 3 is negative 6. 3 times 4 is 12, minus 2 is 10, and then 3 times 33 is 99, minus 25 is 74. Okay, now at this point column 1 is set, and so now I'm going to move on to column 2. And again, I'm trying to get 1s down the diagonal here, so the next step would be to have this 7 turn into a 1. Well, if I just simply multiply all the numbers in row 2 by 1/7, then I'll have that 7 turn into a 1 and still keep the 0 to the left of that. Okay, so that's what I've done here on the next step. I'm getting a new row 2 by taking 1/7 times the old row 2. Rows 1 and 3 are going to stay as is. 0 times 1/7 is 0. 7 times 1/7 is 1. Negative 7 times 1/7 is negative 1. Negative 63 times 1/7 would be negative 9. Okay, now directly below that 1, I need a 0. Right now it's a negative 6, and so I'll need to do something to row 3 where I have this number now turn into a 0. Also, I don't want to mess with row 1 with the 0 here at the beginning of the row. Okay, so my only option for having this negative 6 turn into a 0 is to work with row 2. I can't work with row 1 because any multiplier with row 1 added to row 3 is going to change this 0 to a different number. I don't want to do that. So you want to take 6 times row 2 plus row 3. 0 plus 0 is 0. 6 minus 6 is 0. That's what I need there. Negative 6 plus 10 is 4. And then negative 54 plus 74 is 20. Okay, now the last thing would be to have this 4 turn into a 1. Well, if I multiply row 3 by 1/4, I'll have this 4 turn into a 1, and I'll also keep the 2 zeros that are right before that. So let me do that. I've got, these 2 zeros are still there. 4 times 1/4 is 1, and then 20 times 1/4 is 5. At this point, I am now in row echelon form because I've got 1s down the diagonal and then 0s in the lower triangular part. When you're in this form, you'll want to convert back to a system, and at that point you'll either know one of the variables or you'll know the answer to the problem. Okay, so I've converted this matrix back into a system. I've got a 1 in front of x, a negative 3 in front of y, a 4 in front of z, and a 33 on the right. In the second equation, I don't have any x's there, but a 1 in front of y and a minus 1 in front of z, and a negative 9 on the right. And then in my third equation, I've got a 1 in front of z and then a 5 on the right. So z is 5. Knowing that z is 5 means that I can plug that number in here and start to work backwards. Y minus 5 equal negative 9. If you add 5 to both sides, that means that y is negative 4. And then we can get x, knowing that y is negative 4 and z is 5. You're going to have x plus 12 plus 20, or that'd be x plus 32 equals 33. Subtract 32 from both sides, so it looks like x is 1, y is negative 4, and z is 5. Okay, and that'd be the answer. Now, in general, the method of matrices is going to be faster than what I was doing here by using repeated elimination, because in this process you're writing the equations down, and in the method of using matrices I'm just working with coefficients. Okay, so in general, you know, matrices I believe is going to be a faster option, since I'm not having to write equations down at each time. All right, so be sure that you know these 4 techniques. We are now done with the worksheet, and of course you want to make sure that you get the homework done and then the quiz.